Welcome back, everybody. Welcome back to the channel. So today we're going to continue talking about parsing statements. So in our statements function, we have for loops here. So we're going to be talking about how to parse for loops today. So first thing we're going to want to do is, and you know what, actually, before we talk about for loops, I'm just going to also throw in here how to process alias declarations as well. So what we'll do is we'll also allow you to basically parse alias declarations as local variables or as local like things, I guess. So if I go to syntax, you can see here, so I'm going to create an alias. So let's say alias I as counter or something. So effectively what will happen is we'll allow the user to parse an alias, and then once we exit this scope or whatever scope it's in, right? So if the alias is like in this scope, then what we'll do is we'll delete the alias immediately once we exit the scope. So you want to support that, and literally to add support for alias declarations, you literally just paste in the same code that you have everywhere else. So we have alias declarations in other spots as well, as you can see. So I'm going to go back to where we were, and what was it at? Whoops. All right, so we have our alias declaration. One thing I forgot to add, we do not want the user to have access declarations. It doesn't make sense to have a public, private, or static, or whatever alias. That doesn't really make any sense because specifically aliases, like in terms of local aliases, you don't want to allow the user to do that. Even though at other levels, like if we create an alias at the class scope level, you can have public and private aliases, but this is going to be considered to be a quote unquote local variable. So we don't want to allow the user to do that. After that, let's look to see how we parse our for statement. So I'm going to go back here, and first you need your is statement or your is function, and you just want to parse for the letters for, so for. Make sure it's an identifier and make sure your token is a for. If so, then of course, as usual, we want to protect against having access declarations, and then we return true because we parsed our statement successfully. Let's go into here and let's see how for statements are. Now, I know I've talked about it in the past about having multiple different variants of for loops. Right now, I'm just going to keep things simple. I still have not come up with a concrete way of supporting for loops with like, just weird formatting. So I'm just going to do it the C++ way where you have like for int I is equal to 0, whatever. You guys know how it goes. So what we're going to do is we're going to create a for statement, and we're going to decrement the current token because if you remember, when we parse a for statement, we have the current token as for. So we want to basically expect for. Now you don't need this token and you don't need this token either. So you can just say false after this if you don't want to add it. But we expect for and the left parentheses. Once we do that, then we check to see if the next token is not equal to a semicolon. So if you guys remember, when it comes to C++, the way C++ handles and processes for loops is you have, your for, and the standard format is, I'm going to go here, I int is equal to 0, but in my language you don't really need to specify the type. You can just say I is equal to 0. I is less than, say, 100, I plus plus. So in for loops, the concept is you have multiple different things that you need to process. So you have the first thing, which is called the variable initialization part of the actual for loop. Then you have what's called the condition expression. And that's going to basically, as we're looping, what we'll do is we'll check this condition at the end of the for loop every single time. And if this condition is true, then we'll jump back up to the top and, continue doing what we need to do. And this is called the iter expression or the iteration expression. So basically this gets called, or whatever expression is right here, runs every time we have reached the last point in our for loop. So that's kind of the concept of how it works. But if you guys remember, you don't really need some of these things. Like, so you don't need all of these things. You can, like, if you don't want to have a variable initializer, then you can just say, semicolon here. Whoops. You can just put a semicolon, and then you can just have a condition expression and an iteration expression. Well, what if you don't want to have a condition expression? Well, then you can do that. Now, is it possible to have an iteration expression? So we have our variable declaration, condition. Yeah. So yeah, and then if you want, you can have a iteration if you want, but that's also not required. So I'm pretty sure some of you guys have seen this final format, which is basically just a 4 and 2 semicolons with close parentheses and then your block. So that is effectively how you create an infinite for loop, and this is kind of how we're going to process it. So I've kind of already explained it, but you basically check to see after you process the left parentheses, if the next token is not equal to a semicolon, that means that we must have a variable declaration here. So we're going to expect I is equal to 0 or whatever format. You guys already know what the format is for variable declarations. So we literally just call parse variable declaration. And of course, we want to plus plus the current token because we want the current token to be like, we want to basically, so we're right here, right? We want to move the current token to I so that way we can properly process our variable declaration. So that's why we plus plus it. After that, we have, so we check for the condition expression. So as you can see here, I create a expression condition AST, and it's called AST for expression condition. This is the condition part of it, so I is less than 10. So after we basically process, our variable declaration, if the next token is not equal to a semicolon, that must mean that we have, what the heck? That must mean we have a condition expression here. So we want to process that. So what we do is we just call parse expression. And then of course, immediately after that, we expect a semicolon. Now, the reason why we don't expect a semicolon after parse variable declaration is, if you guys remember, if I scroll down, variable declaration already forces you to have a semicolon. And you know what's really cool about this? The fact that I'm calling parse variable declaration, that allows me to basically hook in all the same technology that I have for parsing variable declarations. So, not only can you create like I, but you can create like A, is equal to 10, B is equal to 1000, C, we don't assign it anything. So like you can create multiple variables inside of this for loop in the variable initialization expression or part of it. So that's really cool when you're using parse variable declaration. So if I go back to parse for statements, so that's why we don't expect a semicolon because it's already handled inside of parse variable declaration. After we process, so here I'm going to remove this code. After we process this semicolon, then we need to check to see if the next token is not equal to the right parentheses. And if so, then we basically parse our iter expression or our iteration expression. So we create a expression iter AST, call it AST for expression iter, and we parse an expression. And that's going to represent, the I++ portion of it. So we have I++, and yeah, so we have that, and then finally we expect our closing parentheses, and then we just parse a block, and that's it. So that's going to be it for parsing for statements. Now let's actually see how this code looks. So I'm going to go to compile, and why do I have AST to string? I don't have any. Okay, compile for each statement. No, it's for, where is it at? For statement. Okay. So if I go up here, I can see cout ast dot toString. And I can't wait to show you guys like how I actually process for statements. It's really interesting. You have to create like labels and stuff, and that's how you figure out where to, like, if you call continue or break, how to do all that code. So it's really interesting. But let's actually see how everything looks. So I'm going to, actually, I think I can just do that. So let's see. So we have this code, remove that, and let's run it. All right, so I've processed our for statement, and if some of you guys are curious, here's the actual output code from the virtual machine. So it effectively, this for statement here generates 16 instructions. You can see here, like, I have a jump at the bottom. So like, I'm going to show briefly how this kind of for loop works. So we have, our I is equal to 0. We move 0 into the EBX register. We call stack move R underscore 2, And what that basically does is that just basically puts this register into, this local variable. So we put the whatever's in EBX into frame pointer plus one, which is the frame pointer of the function that we're currently called in. And then after that, we basically load that value back. Now, this code is very inefficient. I don't have the optimizer build yet, so it's going to be kind of redundant stuff that's happening. But basically, after that, what we do is we then call this expression here. So we basically load the value of I, which as you can see is frame pointer plus one, into the EBX register. We put the number 10 into the EBX register, and then we basically load the value after. So we basically load I, push it onto the stack, load 10 into EBX, and then load the value of I back into a different register called ECX. And then we basically say I is less than 10. And I is going to be an ECX because we loaded it after pushing it on the stack. EBX is 10 because that's the limit value. So we check that, and then we have some stupid code here that I am still working out on fixing, but we basically jump not equal to. So we jump to 17, which is not, it's not in this code fragment here, but basically what that would do is just jump to the end of this for loop. And then what we do at the end, you can see here we have the iter expression where we have, we load the value, frame pointer plus one, which is I, we put that value into a different register, we increment it, and then we load it back. So it's basically just saying I plus plus. Again, this is very inefficient. There's better ways to do it, but that's just what I have now. And then after that, we just jump to 3. So we jump back up to the top, which is, and you notice it's after the initialization. So if I were to actually, like, if we have this code and I were to rearrange it in the way that the compiler sees it, we basically have this, which would be considered to be out of scope. So we'd have like I plus 1 or I is equal to 0. Then I would have if I is less than 10. Whoops, what is going on? So I would say I is less than 10, I plus plus, and yeah, that's, so this for loop would basically represent this. And I would basically go to check, and I would put a semicolon here and then create a label called check. And this is basically what the for loop and this code fragment gets generated as. So very interesting stuff, but let's actually look to see what the actual code looks like. We're getting pretty close to the compiler and the backend, so I'm pretty sure some of you guys are like eager to figure out how everything works. So I'm just giving you little nuggets here and there. So we create our AST4 statement. We have our for loop, and we have all these unnecessary, you do not need these characters. So yeah, you can just ignore that. But we have 4 ASTs. So we have here, let me actually go back. Come on. All right, so we have all of that. So we have 4 ASTs. The first AST is the variable declaration part, or the variable initialization part of it. Declare a variable, we assign it 0. Pretty straightforward. Second one, we have our for expression condition. So that's going to be, I is less than 10. So we have our expression, we have our less expression. Now we've already gone through how to parse math expressions, so you guys know what this is. We have a left expression, which represents 1, or represents I, and then we have a right expression, which represents 10. So that makes sense. Then we have our for expression iter. So we have the I++ portion, which is just an expression of a dot notation call expression of I, and then because of the way that we process dot notation call expressions, we have a post increment expression tacked on to the end of this dot notation call expression. So that way we can just process it contextually. After that, finally, we have our block for our for loop, and that's it. So that's going to be it for today, guys. As usual, if you guys have any questions, definitely put them in the comment section below. And of course, if you guys would love to help support the channel, definitely head over to my GitHub repository at androidevcd/sharp. And when you get there, watch, star, and fork this repository. That's going to give this repository a lot more visibility and let other developers know this language exists. Also, if you're interested in kind of seeing what I do on a daily basis with the language, you can check out the remastered branch. And that's going to pretty much contain, like, this is where I do most of my work pretty much on a regular basis, where I do updates, usually sometimes daily. I try to stick to that, but sometimes it's a little more spread out. You can check out the commits file or the commit section. and you kind of get a gist of what I've been doing without really having to look too deep into the code because I write some pretty wordy commit messages. Also, if you're curious about maybe some of the things that I've done in the past to the language, or maybe stuff that I'm looking to add into the future for this YouTube series and other stuff, then you can check out the docs folder. And in there's two main files. There's the changeless file that's going to be pretty much everything I've done already to the language, like in the past, in terms of updates, bug fixes, features. And then you can check out the roadmap file. I update this one pretty frequently, actually, and this is going to pretty much contain not only everything that I've already done to the language, but also features that I'm looking to add into the future. So definitely recommend checking this out. This gives you a lot of insight into the language. And yeah, so that's going to be it for today, guys. As usual, if you guys are new to the channel, definitely consider subscribing, and until next time, I'll see you guys later.